What is OSPF? OSPF, or Open Shortest Path First, is a link state interior gateway protocol used for dynamic routing. Unlike static routing, OSPF automatically discovers and updates routes, reducing the need for manual configuration. Because it's open standard, OSPF works across routers from different vendors, not just Cisco. It's also highly scalable, making it ideal for both small and very large enterprise networks. OSPF supports IPv4 and IPv6, as well as VLSM and CIDR, giving networks flexibility and efficiency in IP addressing. What does OSPF solve? OSPF addresses several challenges that static routing can't handle effectively. First, it helps prevent routing loops by using the shortest path first algorithm to calculate the most effective loop-free path to the destination. Another key problem OSPF solves is scalability. As networks grow, adding new routers don't require reconfiguring every device. Instead, OSPF allows you to simply configure the new router, and the rest of the network will automatically adapt and learn about it. How does OSPF work? OSPF works by forming adjacencies between routers within the same area. Once connected, these routers exchange information using link state advertisements. The LSAs are stored in the link state database, which gives each router a complete map of the network. With this map, OSPF routers run the shortest path first algorithm to calculate the most efficient path to each destination in the network. What are some features of OSPF? OSPF is open standard, which means it works across routers from different vendors, giving you flexibility in mixed environments. It supports VLSM and CIDR, allowing for efficient IP addressing and subnetting. OSPF scales very well for large networks because, unlike RIP, it does not have a hop count limitation. It also uses the SPF algorithm, ensuring the most optimal paths are always chosen. Some key terms to know with OSPF. Area, a logical grouping of routers to simplify management and reduce overhead. Router ID, the unique identifier for a router in OSPF, often chosen from the highest IP or a loopback. Neighbor, another OSPF-enabled router that forms a relationship with your router. Adjacency, a deeper relationship where neighbors exchange routing information. LSA, the messages routers send to share link state information. LSDB, the collection of all LSAs representing the full network topology. Backbone area, the central area all others must connect to. Backbone router, any router that resides in area 0. ABR, a router that connects one or more areas to the backbone. When working with OSPF, you need to know two things: administrative distance and metric. Administrative distance is how a router decides which routing source to trust when multiple protocols provide routes. OSPF has a default AD of 110, which means it's less preferred than EIGRP at 90, but more trusted than RIP at 120. Metric in OSPF is based on cost, calculated as reference bandwidth divided by interface bandwidth. The lower the cost, the more preferred the path. By default, Cisco uses 100 megabits per second as the reference bandwidth, but you can adjust it for modern, faster links. When designing OSPF, there are a few key guidelines to follow. Backbone requirement. Every OSPF design must have a backbone area, also known as Area 0. All other areas must connect to Area 0, either directly or through a virtual link if needed. Unique router IDs. Each router must have a unique router ID. A loopback interface is often used for this because it's always up, making the router ID stable. Hierarchy design. Break large networks into multiple areas to improve scalability and reduce LSDB sizes. Keep areas simple. Try to avoid too many routers per area. Smaller areas means faster convergence and easier troubleshooting. Here are some essential OSPF commands you should know. Router OSPF followed by the process ID. This enables OSPF and puts you in OSPF configuration mode. Network followed by the IP address, wildcard mask. Area followed by the area ID. Activates OSPF on interfaces that match the given network range. Show IP OSPF neighbor. Displays OSPF neighbors and their adjacency states. Show IP OSPF route. Shows the routing table entries learned via OSPF. Show IP protocols. Displays OSPF process IDs, the router ID, and other key protocol details. Now we'll configure a simple single area OSPF network. To enable OSPF, use the command router OSPF followed by the process ID. In this case, we'll use process ID 1. Next, we'll configure a router ID on router 1. We'll use 1.1.1.1. Now, we'll specify which networks OSPF should run on. On router 1, we'll enable OSPF for the 10.0.12.0/30 network. To do this, we'll use the wildcard mask, which is simply the inverse of a subnet mask. For a /30 prefix, the wildcard mask is 0.0.0.3. Finally, we'll assign a network to area 0, since everything in our lab will run in a single OSPF area. On router 2, we'll use the router ID 2.2.2.2 and enable OSPF on both the 10.0.12.0/30 and 10.0.23.0/30 networks using their wildcard mask and place them at area 0. On router 3, we'll use the router ID 3.3.3.3 and enable OSPF on the 10.0.13.0/30 and the 10.0.23.0/30 networks using their wildcard mask and place them in area 0. As we can see from the sys logs, OSPF neighbor relationships have successfully formed. On router 1, we'll run the command show IP OSPF neighbor to verify our OSPF adjacencies and see the details of the neighboring routers. As we can see, router 2 is now neighboring with router 1, and we see its address via the segment of R1 and R2. We also see R3 is neighboring with router 1 via its segment of R1 and R3. R2, we see R1 as a neighbor via the segment of R2 and R1, and R3 via the segment of R2 and R3. R3 is neighboring with R2 via the segment of R3 and R2, and R1 via the segment of R3 and R1. OSPF complete.